Okay, so we're moving on to part two of uh, section 10.2 curves, or sorry, 10.1 curves defined by parametric equations. I just wanted to take a second to talk about, what's important here. So what I'm trying to do here is I'm trying to teach you, given parametric equations, I'm showing you how to draw the curve that is defined by those equations. And that was the example I did in the last section, where we plugged in values of t and we got, points. We got values for x and y and we plotted those. The other thing that you want to take from this chapter is there are certain special parametric equations that you want to, know the shape of those. So for example, in the last example, if I were handed those parametric equations, if you look back at those in the notes or in the recordings, so we had the parametric equation x is equal to t squared minus 2t and y is equal to t plus 1. So if I were looking at that, I wouldn't have any idea what the shape of that is right off the top of my head. I would have some sort of idea because of the t squared here, but that comes with a little bit of practice. But so, the point behind this is, I'm teaching you how to draw things like this. You don't need to know what these things look like off the top of your head, but you want to be able to draw them and sketch them in case you do need to know what they look like. And also know how to solve, you can solve the second equation, y is equal to t plus 1 for t, plug that back in for x, and you will get, an implicit equation for the curve. So I'm going to move on to the next example, and this is an example of something that you want to remember the shape of. So we have the parametric equations, x is equal to cosine of t, and y is equal to sine of t. And t is between 0 and 2 pi. So when you're looking at this, the first thing you should notice is, the x-coordinate is given by the cosine, the y-coordinate is given by the sine, and if you start thinking about, does that remind you of anything? The first thing you should think of is the unit circle. So if you remember on the unit circle, things are defined by, the x-coordinate being cosine, the y-coordinate being sine. And so you can see that this equation does satisfy the relation x squared plus y squared is cosine squared t plus sine squared t. This is equal to 1. So, no matter what, this relation has to hold. And so, you can draw a couple things, you can draw a couple points here, but, this equation right here, x squared plus y squared is equal to 1, that does describe a circle there. So this parametric equation is just an equation for the unit circle. And this one is traversed counterclockwise. And you get that by plotting points for this. So this is x, this is y. And you get the direction that the curve traces out by plotting points for this and seeing which direction they're going. But so this is one that you want to remember. The parametric equation of a circle is x is equal to cosine of t, y is equal to sine of t. We're going to get more into that when we talk about polar coordinates in a few sections. I think next week we talk about polar coordinates actually. And that's going to be, using using circles to identify points. Let me just say this. This is the point. So this point right here corresponds to the t equals 0 and 2 pi. So when you do this, you get back to the same point, and you traverse, counterclockwise in this case. So let us move on to the next example. And we're going to use what we just learned here to get an idea of, curve represented by x is equal to sine 2t, and y is equal to cosine 2t. T is between 0 and 2 pi. So you'll notice here the difference between this one and the last one is the factor of 2, and also, in the last one, x was cosine. This time, x is sine. So that's gonna change some things. So let's first observe that x squared plus y squared, which is equal to sine squared of 2t plus cosine squared of 2t. This still satisfies the Pythagorean identity. This is equal to 1. So this equation still satisfies x squared plus y squared is equal to 1. So this thing is a circle still. So its graph will be a circle. The difference is, if I plug in t equals 0, I'm going to get x is equal to sine of 0, which is 0, and y is equal to 1. So my starting point for this circle is going to be here. So this one corresponds to t equals 0. And so what you should notice now is, so t goes between 0 and 2 pi. So if I look at these equations, x is equal to sine of 2t, y is equal to cosine of 2t. At t equals pi, I'm going to be at x is equal to sine of 2 pi, y is equal to cosine of 2 pi. So at t equals pi, I've gone around the circle once. So this happens at t equals 0, t equals pi, but I'm not finished. At t equals 2 pi, I'm going to get, let me do it, yeah, we'll do it here. So so at t equals 2 pi, I'm going to get x is equal to, so that x is equal to sine of 2 times 2 pi, 4 pi, and y is equal to cosine of 4 pi. These things are periodic, so I get 0 and 1 again. So this is actually what this is. This is the graph of a circle that I've transversed, or that I've gone around twice. So this graph here, its graph is still a circle. So if you've used a graphing calculator and done parametric equations before, there's an option to graph with this. You can watch this happen. So you'll see the circle happen once. You won't see it go around again. But this equation will give you, the equation of a circle that goes around twice. You might be asking yourself, why does this matter? Why do I need to, describe the graph of a circle where it's wrapped around twice, and I can't even see that it's wrapped around twice. So this is really useful. So my background is in physics. When I'm doing these problems, most of these applications I'm going to give you are going to be in physics. But so if you were trying to, determine the motion of a particle, so this would be what this could represent the motion of a particle in a magnetic field. Particles in magnetic fields do circles. So if you were, a physics person and you were wanting to describe that, that's what you would use. And beyond that, there are other applications, just anything where you're trying to represent circular motion, this would be good for. So I'm going to do one more example, and I think that's going to about hit 10 minutes. And then we'll start a new video. So we have the example. So we want to find parametric equations for the circle centered at the coordinates hk and radius r. So let's assume, h is here, k is here. So the idea is I want my circle to have center there. It's going to look something like this. And so first thing is I want to figure out how to make the radius of my circle r. And And so you'll remember that, the the equation of, so previously, we had, in our first example for this video, we had x is equal to cosine of t, y is equal to sine of t, and this gave us a circle of radius 1. And these things satisfied x squared plus y squared is equal to 1. The general equation of a circle is x squared plus y squared is equal to r squared. So, if I want to, instead of getting a 1 here, I want to get an r squared, all I have to do is take these equations and put an r in front of them. And that'll make my radius r. And you can check this if you do x squared plus y squared. This is going to be r squared cosine squared t plus r squared, let me fix that too, sine squared t. And you can pull the factor of r squared out. You're going to get cosine squared t plus sine squared t. And this is r squared times 1, so this is just r squared. So I'm going to get, x squared is equal to x squared plus y squared is equal to r squared. So doing this, the x equals r cosine t, x equals r sine t, that takes care of the circle of radius r. Now if I want to, change the center of the, if I want to change the center of the circle, so I want to go from x equals 0 to, x equals h. And I can do that just by adding h. So to shift center of circle, you're just going to add the shift. So, what that means is, if I want the x coordinate to be centered at h here, I'm just going to make this h plus r cosine of t. And the same thing in the y direction. I'm going to do k plus r cosine of t. And these will be my parametric equations for the center circled at hk. Circle centered. With radius r. H and k can be negative. That's fine. You'll just plug in negative numbers there and it'll shift them down or to the left, whatever you're doing. And so you want to kind of start getting getting into the habit of understanding these shifts and these elongations. So a shift to the right and left and parametric coordinates, parametric equations. You just add whatever you want to shift to, and so that'll take care of this example. I'm going to move on. We're going to see how to, sketch some more stuff. So we'll see what that means.